Okay, Assalamualaikum and very good morning. So for today we continue our lesson yesterday. Recap for the notes that we have learned yesterday. For three-hinged arch, you are given a parabolic equation. Okay, so this is parabolic equation that you need to remember. Okay, another one is slope. Slope, you know that slope is y divided by x, right? So from dy over dx is equal to tan theta. You got tan theta is equal 4h over L squared, L minus 2x. So these both equation you need to remember. Okay, so I already highlight here that you need to remember for both equation. So for y, okay, you see the arch, imaginary arch equation here. Alright, so to solve imaginary arch, for example, for this parabolic equation, okay, you can use inside this question. Okay, for example, first we have to sketch imaginary arch here. Okay, we have to sketch imaginary arch here. So this imaginary arch is representing after you mirroring this arch. So you got should be symmetrical arch here. Okay, so for this question you need to find YB. So we use this equation. Okay, alright. So in this equation you have H, L and X. So H for this equation is 7 meter. L, remember you have to calculate for all length of span. So for this equation is L is equal to 30 meter. And then X located here. So if you elongate your length, okay, from 50 meter, this one 10 meter, so you have residual of 5 meter. So you get X equal to 5 meter. So inserted all these H, L and X into this equation, you got YB is equal to 3.9 meter. So this YB is 3.9 meter. Okay, so for this arch you need to remember two equation. Alright, so next, so you have one exercise, okay, two exercise to solve here. Alright, so this is first equation, the first exercise. So in this exercise is a three-hinged arch. In this figure you have to determine all reactions. Okay, and then you have to find bending moment. Okay, bending moment at 25 meter from support B. 25 meter from support B. And then you have to find thrust and shear force. So thrust here denoted as N and shear force denoted as Q. So you have to find thrust and shear force at point D and point E. Okay, so first step what you should do is First step, you should sketch a free body diagram. Free body diagram for this equation. So carefully, if you want to sketch again, so this is AY, this one is BY. So you need to remember that arch is experiencing compression force. So that we have to put the horizontal force in pushing forces. Okay, pushing force. So that your AX is in this direction and BX in this direction. So carefully to sketch again your loading. So hopefully you not leave any loading. Okay, you have on top UDL 10 kilonewton per meter. Alright, so this is your free body diagram. Okay, sorry. Okay, I have to sketch it again. And then this another free body diagram. And then second step, you need to find direction. You have to solve all directions AY, BY, AX and BX. Okay, so start with total Fy. So in this direction is positive, so you have AY plus BY minus 8 minus 10 times 20. So this one is 20 meter. Okay, is equal to 0. So this is the first equation. Okay, and then you do Fx in this direction positive, so you have AX minus BX. So remember you have another one 5 kilonewton here, minus 5. So this is second equation, and then you do for the whole structure, taking moment at A equal to 0. In this direction positive, clockwise positive. So you have if taking moment at A equal to 0. So you have 8 minus by minus 5. Okay, so your center gravity here, so this is direction. Okay, so 8 times 10 meter, so you have distance 5 meter plus 10 20 10 times 20, and then in this direction how much? Okay, so because of in the middle, so that this is 30 meter. Okay, so minus 5 times ye. So we don't know this ye, so you have to find it first. Okay, minus by times 60 meter go to 0. Complete. Okay, so you need to find you need to find ye first. Ye. Okay, so ye is equal to 4hx divided by L squared, L minus x. So h you get 15, L you get 60 meter, and x in this ye, x is 10 meter. Okay, insert into equation. You got ye is equal to 8.33 meter. So you can insert into this equation. Okay, sorry. So you got by, you calculate, and then you got by is equal to 100.64 kilonewton. Okay, you got by, and then next you have to solve for this equation. So ay is equal to 208 minus by, 208 minus 100.64. So you got ay 107.36 kilonewton, and then x and bx, how do you solve it? Okay, you need to consider right hand side. Okay, we consider right hand side here, right hand side. Okay, we cut for right hand side. Right, so if we sketch it again. Meter. So you got by here, this one. Okay, by is 100.64. So you don't have, you want to find bx, so be careful, you have 5 kilonewton here and then another UDL here, half, with the distance of 10 meter. Alright, so take a moment at C, here C, so take a moment at C equal to 0. Okay, you have this one, this one, then you have this one, and then bx, this one. Okay, so minus 100.64, this one, minus 100. Okay, this one minus 100 times 30 plus bx, this one bx, okay, clockwise, plus bx times 15. Okay, in this equation 15, and then plus 5, so you have 15. You have 15 here, 15 meter, and you have YE here, so you have the residue here, so that 5 times 15 minus 8.33 plus 10, this one 10 times 10 meter times half, 10 divided by 2 equal to 0. So you get bx, you calculate, you get 165.72 kilonewton. Okay, so that you get ax. Okay, from this equation, so you get ax is equal to 5 plus 165.72. So you get 170.172 kilonewton. So complete for the reaction. So got full marks for reaction. And then we go to the next question. Okay, next question need you to find bending moment at 25 meter from support B. Okay. Then from support B. Okay. So in this question, 25 meter. From support B. Okay. So you need to find bending moment here. And then we sketch it again. Okay, you get BY. How much BY? by 100 bx (165). Okay, you have 5 kilonewton at YE 8.33 meter, and then you have 25 meter here. Okay, x equal to 25 meter, and then at 25 meter actually, okay, this one 10 meter, so this is 20 meter. Okay, okay, I erase it first. Okay, 25 meter. Okay, this one is 10 meter. Okay, if 10 meter here, 20 meter, so you have another residual here 5 meter, and then you got the UDL at 5 meter. 5 meter, 10 kilonewton per meter. Okay, you have x equal to, so you have, if we consider this one as F, so you need to find YF. Okay, so to get moment at F in this direction positive, so you get MF here. Alright, so taking moment at F equal to 0, this MF included into the equation. So MF in this direction is positive, clockwise. So MF okay, you need to find YF first. YF is equal to 4H 15, X 25, L 60 squared, 60 minus 25. So you get YF is equal to wait 14.58 meter, and then you find the taking moment at MF. Okay, this F we denote as F, so taking moment at F equal to 0, so you got MF, and then this one minus 100.64 times 25, and then this direction plus 165.72 times now YF 14.58, and then this one plus 5 times YF minus 8.33, 14.58 minus 8.33. Any others load left? No. Okay, so 1 2 3 4 5, 1 2 3, 4, another one. This one, okay, 100, yes. 5, yes. Oh, this one, 10. Plus 10 times 5 meter and 2.5 meter equal to 0. And you got MF is equal to negative 56.45 kilonewton meter. Okay, because of this is negative, so our first assumption in MF in this direction is actually in this direction. Okay. Okay, clear. So we got a bending moment at 25 meter from support B. Okay, next we have to find thrust and shear force Q at point D. Okay, at point D. At point D, okay. Here is point D. Alright. Okay. First step, first step, you need to consider, you have to see what loading experienced at point D or located at point D. So here you can see there is 8 kilonewton here. Okay, then you have to write a note here. If there is a load at point given or at a point that you want to find, okay, then you should do N thrust force and Q shear force for both with and without load. Okay, right, clear here. Okay, so first what you should do is you write at point D. Okay, we do a without load first. Without load, okay, you have to sketch. You have to sketch okay, this is point D. So without load, first AY, this one AX. Okay, okay, if you cut here, okay, you cut here at point D, so you have force acting compression, and then you have a shear force. Okay, you know that shear force is in this direction, right? Okay, so that you have shear force here, and then this one thrust force. Okay, what is the angle here? You need to find. So this angle bring to here and here. Okay. Okay, alright. So okay, this blue arrow representing here and representing here. Okay, and then green OQ representing here and representing here. Alright, so because it is vector, you need to do it this arrow in this direction. Okay, theta, how about the theta? Where do you want to put the theta? So theta here. Okay, follow the shape. Follow this shape. Follow this shape. Okay, you bring it here, theta, and then here theta. So this theta here is similar with theta here and theta here. Okay, did you remember that this concept nearest theta is equal to cos theta? So that this one, okay, you have to find what is AY and AX first. So in this question, AY is AY. Okay, AY is AY is 107. Okay, and then AX is 170.7. Okay. Hmm. One zero seven. Wait ah. Continue again. One 107.36. AX is 170.72. Okay. Alright. So Right, so you put here because of mention nearest theta is cos theta, so this here is 170.72 cos theta. This one far from theta is 107.36 sin theta. Okay, right, so nearest theta is cos theta. This one cos theta, this one sin theta. Okay, this one cos theta, so this one is sin theta. Okay, so we need to make a equation, resolve this equation in this direction. So previously we know that theta fy in this direction, right? And then theta fx in this direction positive, and then in this direction positive for fx. So same with this n and q. So you need to solve for fy. Fy here is in this direction, fy. Okay, so we get this direction positive. This one n, this one q. Okay, alright, so n, it replace for fx. So for example, okay, sorry, so for without load, okay, we draw the free body diagram first. Sorry. Okay. Then n, so n in this direction, theta, so theta here and theta here. Okay, so AY is 1073.36. Okay, AX is 170.72. This one nearest theta, cos theta. This one far from theta, sin theta. So if you resolve, okay, how do you get theta? Alright, I'm missing this equation. Okay, so okay, back. How do you get theta value? How do you get theta value? So at point D. D is happen at x equal to 10 meter. Okay, so D is happen at 10 meter. Yeah, okay, 10 meter. So that you need to find slope at x equal to 10 meter. So formula for slope, you remember, slope is equal to tan theta is equal to 4h over L squared, L minus 2x. Okay, so you get tan theta is equal to 4, h is equal to 15 meter, L is equal to 60 meter. 60 minus 2, L minus 2x. So you get theta, tan theta is equal to 0.667. So theta is equal to tan inverse 0.667. You get theta is equal to 30.69 degree. So this theta is 33.69 degree. Okay, so then you can resolve it for N and Q. Resolve sorry, okay. Okay, resolve in Q direction. If you see here, Q is in this direction. Okay, so it taking in this direction is positive. Okay, alright, so you got this one, Q, this one, and this one. Okay, so Q in this direction is positive. Alright, so we start with Q first. So Q this direction is positive, so plus 170.72. This one is far from theta, so sine theta. Theta is 33.69. Okay, and then in this direction, so minus 107.36 because of it was nearest theta, so that cos theta equal to 0. Okay, calculate Q. You get Q is negative 5.369 kilonewton. Alright, and then next you resolve in n direction. Okay, n direction, this direction positive, so this direction positive. Okay, so you got n positive, okay, n positive, minus because of in this direction, so minus 170.72 cos theta, cos 33.69, and then in this direction juga, so minus 107.366 sine 33.69 equal to 0. So you got n is equal to 201.6 kilonewton. Okay, this one is without load. Okay, okay, for this question you have 8 kilonewton here, so that 8 kilonewton here. Alright, so that you have to do it again for Q and N with load. Okay, so next, we do for at point D. Point D is x equal to 10 meter with load. Okay, we copy it again, copy the diagram, we copy the diagram exactly like this, but we include 8 kilonewton here. Okay, alright, so we copy it again. One 107.36. And 70.72, N in this direction, Q in this direction, so you got 8 kilonewton. Okay, how about the resolve for this? Okay, N Okay, copy like that. Okay, and then Q in this direction, so it should be parallel. Okay, like that. Okay, so how do you find the Q? Q here, so Q here, theta here, theta here, theta here, and theta here. Alright, and then resolve in Q direction, in this direction positive, is actually similar with this equation, but included this 8 kilonewton. Okay, alright, so Q plus 170.72 sine 33.69 minus 1707.36 cos 33.69. In this direction positive, so this one similar direction, so positive 8 nearest theta, so that cos 33.69 to 0. So calculate it again, you get Q is equal to negative 12.03 kilonewton. And then next you resolve in n direction. Okay, so n direction, in this direction positive, this direction positive. Okay, you got this one, this one, this one, and this one. Okay, so actually it's similar with this equation, but you have to include this 8 kilonewton sine theta. Okay, so and copy it again. Okay, n minus 170 in this direction positive, so this direction, so positive, plus 8 sine 33.69 equal to 0. So you calculate it again, n is equal to 197.16 kilonewton. Okay, clear, okay. So next question need you to find thrust and shear force Q at point D and E. So next, point E. Okay, point E. Okay, this one, point E. You have loading here 5 kilonewton, so that you have to do with and without load, because of there is 5 kilonewton here. Okay, let's go. So we do for theta first. Sketch it first. Okay, at point E, here E, X is equal to 10 meter, similar with Y D. So if you got similar X, x equal to 10 meter, so YE is also equal to YD. Okay, so YD is equal to YD. YD is equal to YE. So theta D is equal to theta E, 33.69 theta. So no need to calculate it again. Then you have to do at point E without load first. Without load. Okay. So you get, by bx. So you have n here and q in this direction. Okay, it should be like this. In this direction, if you cut here, if you cut from the left hand side, q in this direction. If you cut from the right hand side, so q in this direction, shear force. Okay, so you have to find by and bx. So by is 100.64. This one is 195.72. Okay, so n in this direction, so that this one and this one. Okay, alright, so q in this direction, so that here and here. Theta here, so that you get theta here and theta here. Okay, next. Resolve in q direction first. So I want this direction positive, so this direction positive. Okay, you get q. Okay, this one. Q. Okay, this direction, so that negative 1. Okay, because of the far from theta, so that the sine theta. And then this one in this direction, so that is similar this direction, so positive 100.6964 nearest theta, so cos theta. So you calculate q, how much. Okay, okay, you should get your theta is equal to your q is equal to wait Okay, next, resolve in n direction. Okay, this direction is positive. Okay, this inverse, this direction positive, and then minus and minus, minus cos theta minus 100 is for sin theta. So n, get this value. So how much? The value is this one should be 8.19. This one should be 193.71. Okay, this one is without loading, and then you do it again, you sketch again. At point E with load. Okay, you have load here 5 kilonewton. Okay, so resolve Q in this direction and then N in this direction, theta here, so similar with here, congruent. Okay, so resolve. Actually it's similar with this equation and this equation, but you have to include this 5 kilonewton. Okay, so resolve in Q direction, copy it again, this direction positive, Q minus Q, so it is here, so minus 5, so far from theta, so this one is 5 sin theta. So calculate Q again, kilonewton, and then you resolve in n direction. Okay, this direction positive, so copy it again and minus 100. Okay, don't forget to include this. Okay, because of vice versa of this direction, so it should be minus 5 nearest theta, so cos theta, 5 cos theta. So calculate it again. Should be you got Q is 10.69 kilonewton and N is equal to 197.87 kilonewton. Okay. Alright. So I want you to do a question 6 ECS 258 June 2018. Okay, so in this question you need to find you need to find all support reaction of the arch. So you need to find AY, AX, EY, EX. Okay, and determine shear force and axial N and bending moment at point B and point D. Alright, so you need to find Q, N and bending moment at point B and D. So you have to cut it and then find out MB. You cut it, you find out MD, and then you have to find N in this direction, Q in this direction, and then another one N in this direction. And in this direction, sorry. You have to find out N in this direction and Q in this direction. Okay, so because of there is loading here and loading here, you have to do both with and without load. This one pun with and without load. So in this equation you have to find moment at B, moment at D, N and Q for B, QB, and D, QD for both with and without load. Right. So all this one is 15 marks. Alright. Submit it at U Future as your attendance before 6 p.m. 24/4/2025. Alright, so we end our class for today here. Alright, hopefully you submit at your future. Alright, thank you class. See you next week, and we probably finish. We probably will do it, the shear force and bending moment diagram, and also axial force diagram for next week. Alright, so thank you. Assalamualaikum and very good morning.